Online students, please all of you confirm in the chat box. Raju. Online students, am I audible? Please confirm. See here. In previous session, very clearly we discussed about views and materialized views. Practically we have seen. So view is the virtual table. It does not contain physical data. Just to select query will be stored. It has one drawback. Less performance will be there in some situations. So to avoid the drawback, materialized view introduced. In materialized view, we maintain table summary physically to improve performance. This thing practically we have seen, but here one problem is there. If you make any changes to base table, those will not be reflected to materialized view because it is giving pre-computed result. So to solve this problem, we have to refresh. To refresh it, three ways are there: on demand, on commit, on time interval. These things very clearly, practically, we have seen. Today is the last session in our course. Sir. Okay. So topic name is indexes. Okay, as I told, okay, at 11:30 I have a session in another branch. So I need to travel from there and I need to have lunch and then I have to come here. So that is why I'm starting the session late today. And today is the last session. See here. What is the purpose of index? Index main goal is this index is used to improve performance of data retrieval. If we want to get data quickly from table, then create index on column. So index main purpose is this one, sir. Index is used to improve performance of data retrieval. If you want to get data quickly from the table, go for index. Let me give one simple example. First, understand this example. You take any textbook. You take any textbook. In the textbook, in the front page, publisher publishes index. You take any textbook, in the front page, publisher publishes index. In the index, what they print? Chapter name, page number. For example, assume that that is Oracle textbook. First chapter name is DDL, page number 1. DML, page number 10. DCL, page number 20. Functions, okay, page number 40. Giants, page number 80, like this. Like this. Book index published by you. Publisher. Book index printed by publisher like this. Why he is printing index, sir? If index not printed, what happens? If you want to refer Jan's topic quickly, it is not possible now. If you want to refer Jan's chapter, what do you have to do now? In the book, assume that the index is not printed, publisher not printed index, but I want to refer Jan's topic. What I have to do now? Is first page Jan's chapter or not? Is second page Jan's chapter or not? Is third page Jan's chapter or not? Every page I have to check. Is first page Jan's or not? Is second page Jan's or not? Like this. How many pages I have to check, sir? 80 pages. Is it not becoming complex, sir? Is it not becoming time wasting process? That is why publisher is printing index. So if index is printed in the front page, if I want to refer Jan's chapter, first I will go to index now. I search for Jan's chapter. Jan's. Like this I'm searching. Jan's found here. Identify page number. I identify page number. Directly I open 80th page. I can refer the chapter quickly now. With book index, I can refer chapter quickly. In the same way, with Oracle index, we can retrieve the data quickly. That is why we create index on column. Always index is created on columns. That's it. This is the purpose. If anyone is asking what is the purpose of index, tell this one. To improve performance of retrieval. Just like with textbook index, we can refer the chapter quickly. With Oracle index, we can refer the row quickly. Just like textbook index is maintaining chapter name, page number, our Oracle index contains column value, its row address. Okay, for example, on salary column, I'm creating index. On salary column, I'm creating index. 3000 employee row address. 5000 salary employee row address. Okay, 8000 salary employee row address. With 8000, 3 employees are there. 3 row IDs it maintains. Okay, salaries. The employee who is getting salary as 10,000 is row ID. The employee who is getting salary as 15,000 is row ID. Like this. Like this, it is maintaining column value and row address in the Oracle index. Just like in the book index, it maintains chapter name, page number. In the Oracle index, it maintains column value. Always we create index on column. If I create index on salary column, salary value, its row address will be stored. If I submit condition like this, salary greater than 10,000 I am submitting. Now what Oracle will do? Oracle goes to index first instead of checking in the table. Salary is greater than 10,000, those row IDs it collects. Using these row addresses, select the row. Using this row address, directly go to row address, fix the row. So quickly we get the data now. Just like if I want to refer DML chapter, I'm going to index. I'm identifying page number. I'm referring chapter quickly. With Oracle index, I can refer the rows quickly like this. Are you understanding? Online students, did you understand the purpose? Good. Next. Indexes. Chapter name is indexes. What is index? Index is one Oracle database object. Just like table is database object, view is database object, sequence, all, procedure, function, trigger, all these are database objects only. In the same way, index is one Oracle database object. Okay, it is used to, index is used to improve performance of retrieval. If we want to get the data quickly from table, create index. Always index is created on column. Remember this. Always we create index on column. It's like book index created on chapter name. Book index is created on chapter name. Our Oracle index will be created on column. So always we create index on column. On which column? A column which is frequently used in where condition. A column which is frequently used in where condition. On that column, we create index. That's it, sir. Suppose my frequent operation is every day. My frequent operation is retrieving data based on salary. Salary greater than 10,000. Salary less than 8,000. Salary greater than or equals to 25,000. Salary is less than 40,000. Every day, my frequent operation retrieving data based on salary. To improve this performance, to improve this performance of retrieval, it is better to create index on salary column. It improves performance. Always we create index on column. On which column? A column which is frequently used in where? On that we create index. That's it, sir. How to create the index? Creating is very easy, but understanding is important. Create index, index name, on table name, columns list. That's it. So creating index is very easy. One line query only. Create index with which name you want to create, on which column you want to create, that column available in which table, tell that. Always index is created on column. On which column you want to create index, tell that. With which name, tell that. Create index with which name you want to create. On which column you want to create. That column stored in which table, tell that. Simple. Suppose on salary column, if you want to create index, write like this. Create index, index name on salary column available in which table? EMP salary. On salary column, index created. Simple. This is a way of creating index. Pay attention, listen carefully. One important point I'm telling. Now you know very clearly, but what it is index, what is the purpose of it, how to create it, you know. 3 points you know, sir. First point, what is index? Oracle database object. Second point, why index? To improve performance of retrieval. Always we create index and column, which is used frequently in the where, on that we create it. How to create it? This is it. This example. On EMP table salary column, we are creating index. Create index, index name on table name, column name. So how index improves performance? I want to tell this point now. For this, I'm telling this point. Listen. Point is important. Listen carefully. Be focused from the beginning to till the end. You have to put your mind here only. Otherwise, you cannot understand. Listen carefully. When we submit select command to Oracle, Oracle performs any one of following two scans. When we submit select command to Oracle, Oracle performs any one of following two scans. What are those following two scans? One is table scan. Another one is indexes scan. When table scan will be performed? if index is not created. When index scan will be performed? When index is created. When index scan will be performed. If index is created, index scan will be performed. If index is not created, table scan will be performed. Understand this example here? Suppose this index is not printed. I'm checking is first page Jans or not, is second page Jans or not, is third page Jans or not. 80 pages I'm checking. This is just like table scan. Slower. To improve performance, we are using index scan. This is just like index scan. Directly I'm going to index first, searching for Jan chapter, identifying page number. Directly I'm going to 80th page, referring Jan chapter here. This is faster now. This is just like index scan. For easy understanding purpose, I'm comparing. If this index is not published, every page you have to check. That is just like table scan. If index is published, directly we are going to index. We are identifying page number. Directly we are going to page. So if index is there, it is faster. Same here also. If index is not created, Oracle performs table scan slower. If index is created, Oracle performs index scan faster. So index scan is faster than table scan. Now, let me explain clearly here. For example, my frequent operation is retrieving data based on salary. So I'm submitting like this. The name comma salary from EMP where salary greater than or equals to where salary greater than 4,500. Like this I'm submitting. Now you tell me, sir. Now which scan will be performed? Table scan or index scan? Why table scan performing? Index not created. Very good. You're listening. So because of till now we didn't create any index. Because of till now we didn't create any index. When we submit this select command, table scan will be performed, but it is slower, degrading performance. My frequent operation is retrieving data based on salary every day. My frequent operation is retrieving data based on salary. So it is better to create index on salary column. How to create index, sir? Uh, uh, uh. Very good. It gives output as table index created. Again, I am submitting same query, sir. Now, because of index created, now which scan will be performed, sir? Index scan. So it improves performance. As a developer, you know this much enough. As a developer, you know up to here, that is enough. But because of I am the trainer, I give complete information to you how it is improving performance. As a developer, if you know, if you create index and column like this, when we retrieve data based on that column, it improves performance. As a developer, if you know up to here, enough. Okay. But how it is improving the performance, let me explain clearly. Try to understand. When we create the index, implicitly, one binary tree will be created. When we create the index, implicitly, one B tree, sorry, balanced tree will be created. One B tree, balanced tree will be created. one tree will be created, sir. Because of tree, it is improving performance. Understand this point now? Its salary column is there. Assume that this employee salary 2,500. This employee salary 5,000. Okay, this employee salary 3,000. Okay, this employee salary 1,500. Okay, this employee salary 1,000. Okay, like this data is there. This employee salary 4,800, 4,900. Okay, this employee salary 2,800. This employee salary 1,200. Like this data is there. And some employees' salaries are same. This employee salary also 1,500 only. Okay, this employee salary also 3,000 only. Like this. This is sample data. Now I am creating index on salary column. When I create index on salary column, implicitly one B tree will be created. They have written tree program. Those who are from CS background, in your academics, in the data structures, you learn the tree concept. A tree is the collection of nodes. Is the node. Node contains data. One left node address and right node address. So node contains three values. One is data, two addresses. Left node address, right node address, it maintains. Node contains three parts, sir. One is what? Data. Another one is what? Left node addresses, sir. Another one is what? Right node addresses, like this. Node contains three parts. Data, left node address, right node address. It's called node. Because of it is main node, this is called root node. Some value takes as root node value. It uses some algorithm for this. Okay. By using some algorithm, it creates root node here. Suppose I'm taking this algorithm. I'm taking maximum salary. I'm taking minimum salary. I'm finding average of these two. Average is 3,000. This I'm taking as root node value. I'm using this logic. Which logic Oracle developers use, we don't know. That is implicit. Implicitly, it is creating B tree. It's not explicit. Which program they developed, we don't know. For understanding purpose, I'm using this logic. Some values it takes as intermediate nodes. This is left node. This is left node. And this is right node. Okay, these middle nodes, I'm calling as the intermediate nodes. So these middle nodes are called intermediate nodes. Okay, for intermediate nodes also I'm using some logic here. Take minimum salary. And the rule tree construction rule is that if value is less than or equals to root node, that will be placed at left side. If value is greater than root node, that will be placed at right side. If value is less than or equals to root node, that will be placed at left side. If value is greater than root node, that will be placed at right side. This is tree construction rule. Those who are from CS background, in your academics, in the data structures, you learn this. Tree construction rule is that, okay, if value is less than or equals to node, that will be placed at left side. If value is greater than node, that will be placed at right side. This is tree construction rule. Okay, understand now. Take minimum salary and root node. Find average of these two. Take this as this intermediate node. take maximum salary and root node, take average of these, take this another intermediate node. 2000 less than 3000, place it at left side. 4000 greater than 3000, place it at right side. So this is the logic I'm using to construct this tree. To construct this tree, which logic I'm using? Observe here. First, how we are getting root node? This minimum value, maximum value, uh, average I'm finding. That is root node value I'm taking. Next, this minimum value, root node value, average I'm finding. That I'm taking as this intermediate node. Okay, this maximum value, root node value, average I'm finding. That I'm taking as another root node value, another intermediate node value. Okay, now construct the tree now. If salary is less than or equal, that will be placed at left side. If salary is less than or equals to 3000, that will be placed at left side. If salary is greater than 3000, that will be placed at right side. Okay. Now, this is left node and this is right node. This is left node. And this is right node. Okay, understand here. So this is left node of 2000. This is right node of 2000. And this is left node of 4000. And this is right node of 4000. Understand now what is first employee salary? Observe here. So like this tree constructed, sir. What is first employee salary? 2500. Is it greater than 3000 or less than 3000? Comes to left side. Next, is 2500 greater than 2000 or less than 2000? Greater means where it will be placed? Right side. Are you understanding? Once again, I'm telling. First salary 2500. Is it greater than 3000 or less than 3000? Less means comes to left side. Is 2500 greater than 2000 or less than 2000? Greater. So comes to right side. So 2500 will be placed here. Salary value, row address. Index contains values and row is in the leaf nodes. So these last nodes are called leaf nodes. In the leaf nodes, it maintains in the leaf nodes, it maintains salary value, row address. See the next salary value, 5000. Is 5000 greater than 3000 or less than 3000? Comes to right side. Is it greater than 4000 or less than 4000? Comes to right side. 5000 will be placed here. A little bit fast I am explaining, sir, because you already know 3000. Okay, 3000 equals to 3000. Observe. If equal comes to left side. 3000 greater than 2000 comes to right side. Next salary 1500 less than 3000, less than 2000, placed here 1500. Row address like this. Next salary value 1000 less than 3000, less than 2000. Okay, in the leaf nodes it arranges in ascending order. 1000 will be placed first. Next 4800 greater than 3000, greater than 4000. Here it will be placed in the leaf nodes. It maintains in ascending order. So 4800. Next salary 2800. Okay, next salary 2800. Okay, so that will be placed at here. Next salary 4900. That will be placed. Yeah. Okay. Next salary, 1200 or otherwise. I'm taking salary as 3500. I'm taking 3500. 3500 is greater than 3000, less than 4000. It will be placed here. Right. Next salary 1500. Comes to left side, comes to left side. Already 1500 value is there. Observe. Value will be stored one time only. With 1500 value, two row addresses it stores. With 1500 salary, two employees are there, two row addresses. If three employees are there, three row addresses. Next salary 3000. 3000 already value there, two row IDs. Like this, it constructs the tree. Is it clear up to here, sir? Now I am submitting query like this. Salary is greater than 4500. Understand now? If index is not created, what happens? First understand this one. Table scan. First observe how many salaries are there. 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 salaries are there. I am submitting this condition, sir, where salary greater than 4500. This condition I am applying. What happens now? If index is not created, it performs table scan. Assume that we didn't create index. It is performing table scan now. How it performs table scan? Observe where condition will be applied on every row. This where condition will be applied on every row now. Is 2500 greater than 4500? Checks like this. False. Is 5000 greater than 4500? True. Is 3000 greater than 4500? False. Is 1500 greater than 4500? False. Is 1000 greater than 4500? False. Is 4800 greater than 4500? True. Okay. False. 4900? True. 3500? False. 1500? False. 3000? False. Like this. How many conditions it is testing? 11 conditions. How many comparisons are happening? 11 comparisons. So number of rows equals to number of comparisons in table scan. If 100 rows are there, 100 comparisons. If 1 lakh rows are there, 1 lakh comparisons. It degrades performance. To improve the performance, we are creating index on salary column. On salary column, we are creating index like this. When we create index like this, implicitly B tree will be constructed like this. Now I am submitting same condition where salary greater than 4500. Same condition I am applying, sir. In table scan, 11 comparisons, sir. In index scan, what is happening? Observe. What is the root? All left side values are less than or equals to 3000. All right side values are greater than 3000. So we are submitting the condition salary greater than 5000, 4500. Salary greater than 4500 means definitely salaries will not be available at left side. These many comparisons reduced or not. So directly it is searching at right side, coming to right side. 4500 that will not be available at left side because left side values are less than or equals to 4000. We want greater than 4500. So again comes to right side. Now is 4800 greater than 4500? True. Is 4900 greater than 4500? True. Is 5000 greater than 4500? True. All these values are greater than 4500. So how with how many comparisons we are getting the result according to this sample data? 3. In table scan, how many comparisons it is doing? 11. Time saved or not? Like this, index improves the performance. Did you get some idea, sir? How index is improving performance? Is it clear? Okay. Now, till now, what we discussed, I'm giving overview on it. Listen. What is index? It is one Oracle database object. Why index? To improve performance of data retrieval. If you want to get data quickly from table, create index. Even in your mobile also, for contacts, index is there. Alphabetical order. If you want to dial to your friend S, directly you can scroll up to yes, because those are in indexed wise, alphabetical order. Even in your mobile also, contacts are arranged in the form of index. Okay, so with indexes, we can get the data quickly. Just like with book index, we can refer the chapter quickly. With Oracle index, we can refer the rows quickly. On which column we create index? A column which is frequently used in the where. On that we create index. How to create index? Create index name on table name, column slash. Suppose I am submitting query like this. Till now I didn't create an index. It performs table scan slower. To improve performance of this retrieval on salary column, I am creating index. After creating index, again I am submitting same query. It is faster. Why faster? Because in table scan, where condition will be applied on every row. Slower. In index scan, B tree will be created. So salary greater than 4,500 means these many comparisons reduced and this comparison also reduced. Directly it is doing only 3 comparisons. So these many comparisons reduced here. So automatically it improves the performance. So from the beginning of session till now, Srichar, I already explained that. Again you are asking. You are correct only. Average value. I already told that part. So someone asked like this. Okay. So that is why to avoid this question only, explain slowly there. But still you are asking. So the point to understand here index reduces number of comparisons, improves the performance. According to this sample data, in tables can 11 comparisons, in indexes can 3 comparisons. Okay, so like this, indexes can reduces number of comparisons and improves the performance. Now, I'm moving forward. Number of comparisons. Okay. Types of indexes. How many types of indexes are there? 2 types. What are those? One is B-tree index. Another one is bitmap index. In B-tree index, again 4 subtypes are there. What are those? Simple index, composite index, function-based index, and unique index. So how many types of indexes are there? 2 types. B-tree index, bitmap index. In the B-tree index, again 4 subtypes are there. What are those? Simple index, composite index, function-based index, unique index. Now, what is simple index? Understand now? Easy. If index is created on one column, always we create index on column. If index is created on one column, that is simple index. On salary column, I am creating index, simple index. If index is created on multiple columns, that is composite index. Suppose on department number and job 2 columns, I am creating index, composite index. Function based index. If index is created based on function, that is function based index. On lower of e name, I am creating index, function based index. Unique index, a column which has unique values. On that I am creating index. On a unique column, we create unique index. For example, department number, unique in department table. Okay, department number column, unique in department table. That is unique index like this. So how many types of indexes are there? Two types. B-tree index, bitmap index. What is B-tree index? When we create index, if B-tree constructed like this, that is B-tree index. If B-tree not constructed, if B-tree not constructed, that is bitmap index. In B-tree index, in the leaf nodes, it maintains values and row IDs. Values, row ID. Salary value, row address. Salary value, row address. Like that. In the leaf node, it maintains values and row IDs. Whereas in the bitmap index, bits will be stored. Zeros, ones. Zero is a bit, one is a bit. Zeros, ones, bits will be stored here. Is the difference? Once again, I'm telling. How many types of indexes are there? Two types. What are those? B-tree index, bitmap index. What is B-tree index? When we create index, if B-tree constructed like this, that is B-tree index. If B-tree not constructed, that is bitmap index. In B-tree, in the leaf nodes, values and row IDs will be stored. In bitmap index, bits will be stored. Zeros and ones will be stored. Is the difference? In B-tree index, four subtypes are there. What are those? Simple index, composite index, function-based index, unique index. What is simple index? If index created on one column, simple index. What is composite index? If index created on multiple columns, composite index. What is function-based index? If index is created on function-based index. What is unique index? On a unique column, we create a unique index. That's it, sir. These, if you know practically, you know indexes. That's it. Theory part is over. Now, these only I'm showing practically now. Observe. Observe, sir. To prove is it performing table scan or indexes scan, we need to see the execution plan. To see the execution plan, you tell me, sir, what is the default server output value? What is the default server output value? Off. How to set this as on? Set server output on. In the same way, default auto trace value off. Default auto trace value off. That is why it will not show execution plan. Default auto trace value off. That is why it will not display execution plan. If you want to see execution plan, set this auto trace value as on explain. How to set? Set auto trace on explain. It's like to set server output on. Set server output on. To set auto trace on explain. Set auto trace on explain. Set auto trace on explain. It shows execution plan to us. So with that, we can understand, is it performing table scan or index scan? Now, this is important, sir. To understand, is it performing table scan or index scan? Remember this. Set auto trace on explain. Let me log in now. Observe. See here. To see execution plan, let me check EMP table data first. Name comma salary from EMP order by salary descending order. This is the data set. Now, I want to get salaries greater than 3000. This is my requirement. Salaries greater than 3000 I want. 3 employees are there. So I'm submitting like this. First set auto trace answer. Okay, show auto trace. Show auto trace. Default auto trace value off. Observe. To see the execution plan, set this as on explain. On explain we have to set. So write like this, set what we want to set, auto trace as which value, on explain. To see execution plan, we are submitting like this. I'm submitting this query now. Select ename comma salary from EMP where salary greater than 10,000. Tell me, sir, till now we didn't create an index. Which scan will be performed now? Table scan or index scan? Sorry? Table scan. Observe, sir. We are getting salaries greater than 10,000. Table scan it is performing. Observe. Table accessed directly it is telling. Table scan. Now, I want to improve performance of it. My frequent operation is retrieving data based on salary. I want to improve performance of it. So create index. Index on salary column. Tell me, sir, how to create index now? Uh, 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 uh. This is which kind of index now? This is which kind of index? Why simple index? Index is created on one column. If index is created on one column, this is simple index. Observe here. Index created, see, sir. After creating index, same select command I'm submitting. Which scan will be performed now? Index scan or table scan? Huh? Index scan. See, sir. I'm getting same output. Salary is greater than 10,000. This query works faster now because index created. It is performing index scan. See here. Index scan performed. We have to see bottom to up. See here. Using index 1. Using index I1. Using indexes I1. It is performing index scan here. Using index I1. Index contains salary value, row address. So the salaries which are greater than 10,000, those row ID is collecting. Okay. Table accessed by index row ID batch it is selling. Observe. So this EMP table accessed by using index row addresses. Then selecting the data. So when we are retrieving the data, first it is going to index. It is performing index scan now. Salary is greater than 10,000. Those row ID is collected. Using that row ID batch table access. Just like in the book index, first we are going to index. Here in index scan, first Oracle is going to index. Salaries greater than 10,000. Those row IDs collecting here. Using this row ID batch, table accessed here, retrieving the data. So that is why it works faster. Are you understanding? That's it. This is simple index. Next, second one, composite index. Understand about composite index now? Okay, did you understand how to check is it performing table scan, index scan? Is this band clear, sir? How to check is it performing table scan or index scan? Set auto trace on next. If index is not created, it performs table scan. If index is created, it performs index scan next. Using I1 index. collecting all row IDs, using row IDs, table access. So it works faster now. Directly goes to row ID, picks the row. Next, composite index. My frequent operation is retrieving data based on department number and job set. I want to get 20 a department clerk records. I want to get 30 a department salesman records. I want to get 20 a department analyst records. I want to get 30 a department clerk records. This is my frequent operation. Every day, I want to work with this data. Based on department number and job, I want to retrieve 20 a department clerks records, 30 a department salesman records. Okay, 20 a department analyst records like this. Based on department number and job, I want to retrieve. So I'm submitting like this. Select e-name, comma, department number, comma, job, comma, salary from EMP, where department number equals to 30 and the job equals to salesman. Now tell me, sir, if I submit like this, which scan will be performed now? Table scan or index scan? Table scan. Till now, we didn't create index on department number and job. So this is our frequent operation. Two columns we are using in the where condition. So it is better to create index on two columns now. It is performing table scan, observe. Table access it directly. Table scan it is performing. 30 department salesman records were getting. Now I want to create index on department number and job. Now tell me, sir, how to create index? Create index. I took on which table, which columns? Index create object. Again, I am submitting same query. Now which scan will be performed? Table scan or index scan? Very good. See here, using index I2, collecting row IDs, using those row IDs, table access now. So this is composite index. If index is created on multiple columns like this, so our frequent operation is retrieving data based on department number and job. So it is better to create index on department number and job. So this is composite index. If index is created on one column, simple index. If index is created on multiple columns, composite index. If index is created on one column, simple index. If index is created on multiple columns, composite index. Composite. Now, by seeing this very clearly, we are understanding here on salary, one column index created, simple index. On department number and job, two columns index created. This is composite index. Okay. Is it clear about these two? Next one is what, sir? Function based index and unique index. Listen carefully. If you don't listen, you cannot understand. So if we discuss these three, that's it, sir. That is index. Listen, function based index. My frequent operation is retrieving data based on name. My frequent operation is retrieving data based on name. I want to get Blake record now. So I'm writing like this. Select star from EMP where ename equals to Blake. I'm writing. Now which scan will be performed now? Tables. I want to improve performance of it. What we have to do? Create index I3 on which table? Which column? This is which kind of index? Which kind of index? Simple index. Why simple index? On one column it is created. Good. Now I want to improve performance of it. So I create index on ename column. Again, I'm submitting same query. Again, I'm submitting same query. Now which scan will be performed, sir? Next scan. Works faster. Okay. Here, no problem. But in real time, when we don't know exact case, we submit like this. Suppose Blake record here EMP table, all employee names are in uppercase. Here employee names are in uppercase. But I don't know exact case now. So when we don't know exact case, we write like this. Select star from EMP. Just a minute. Select star from EMP where lower of ename equals to lowercase Blake. So every employee name we are comparing with lowercase, we are comparing with lowercase Blake. Now which scan will be performed, sir? Which scan will be performed now? Table scan. Because index create on which column? Ename. But we are using what here? Lower of ename. That is why index is not working, sir. It is performing table scan. Index create on ename. Index not create on lower of ename. So create index on lower of ename now. How to create index on lower of ename? Create index I4 on EMP table lower of ename. Now this is called what, sir? Function based index. Why we are creating function based index? Did you understand this point? When we don't know exact case, we submit like this, but it is performing table scan. To improve performance of it on lower of ename, we are creating index. After creating index, again submit this query now. It performs index scan. It is faster. Next. This one only I'm showing. Observe now. I want to get Blake record. See, sir. Blake record I want to get. So what I'm writing? Select star from EMP where ename equals to Blake. Blake record I'm getting. Which scan will be performed, sir? Table scan. We're getting Blake record here, but it is performing table scan. Correct output only, but table scan it is performing. Degrades performance. So to improve the performance, I am creating index on ename column. This is simple index. Now again I'm submitting same select query, working perfectly. Index scan it is performing okay, improving performance okay. But I don't know exact case. When I don't know exact case, I write like this: lower of ename equals to Blake. Lower of ename equals to Blake. Like this I write. If I write ename equals to Blake, index scan working. Ename equals to Blake. If I write like this, index scan working. But I am writing lower of ename equals to Blake. Now it's performing table scan, sir. It is performing table scan now. Because index create on ename. Index not create on lower of ename. If I write ename equals to Blake like this, index working perfectly. Okay. Index scan it's performing. I'm sorry. Oh, I scrolled so much up. Okay. See here. After creating index on ename column, if I submit like this, it performs index scan now because index create on ename column. Index scan it is perform. So it is improving performance. Okay. But if I write lower of ename, It is performing table scan again. Again, it's performing tables. I want to improve performance of it. So I have to create index on lower of it. Create the index now. Create index. I4 on EMP lower of ename. See here, index created. Now it is performing index scan. Observe, sir. I4. So this is the index created on function. This is called function based index. So if index is created on one column, if index is created on one column, simple index. If index is created on multiple columns, composite index. If index is created on function, function based index. Is it clear up to here? Again, we will not touch this. Is it okay, sir? Last two. With this course will be finished, sir. Unique index and bitmap index. Listen. If you don't listen, you cannot understand, sir. Listen. What is unique index? A column which has unique values. On that, it is better to create unique index. A column which has unique values, on that it is better to create unique index. Okay, what is the advantage we get? In future, if anyone is entering duplicate values, it does not accept duplicates. Does not accept duplicates because of unique index. Okay, unique index. Because of unique index, it does not accept duplicates. Do you know primary key, sir? Primary key does not accept duplicates, right? Do you know unique does not accept duplicates, right? Why they are not accepting duplicates, you know? On primary key column, implicitly, unique index created, sir. Because of unique index only, primary key does not accept duplicates. On primary key column, implicitly, Oracle is creating unique index. That is why primary key does not accept duplicates. Primary key does not accept duplicates because of unique index created on primary column. So that is why on primary key column, we never create index explicitly. Same point applicable for unique also. On primary key column, on a unique column, we never create index explicitly. Implicitly, it creates unique index only. Because of unique index only, primary key, unique are not accepting duplicates. How to create a unique index? First, you tell me syntax of index. To that one word I add. How to create index, sir? Uh, uh, columns list. To create unique index, one word I'm adding extra. Which word I'm adding? This is a way of creating unique index. This word extra I'm adding. Unique. If this unique is not there, it's not unique index now. It's normal index. If I write unique here, this is unique index now. Understand this point? In department table, see the department table data first. Select star from department number. Sorry. Select star from department table name. See here. Department table has 4 departments information observed. 5 are there. Okay. Select star from department. Department table has 5 rows observed. Now on this department, my frequent operation is retrieving data based on department number. Or department name. Okay, my frequent operation is retrieving data based on department name. A department name unique or not? In department table, department names are unique or not? Once we enter department HR details, again we never enter HR department details. Already entered. So on D name column, I want to create on D name column, not department number, sir. D name column I am creating. In the department table, department names are unique. Now I want to get sales department record. So I'm submitting like this. Select star from department where department name equals to sales I'm writing. Tell me, sir, now which scan will be performed now? Table scan. Table scan performed, observe. Degrades performance. I want to improve performance now. So D name unique column or not? Okay, D name values are unique or not? This is unique valued column. On a unique valued column, it is better to create unique index. So create unique index now. How to create unique index? Create unique index. UI1 on which table? Which column? See here, index create observe. Again, I am submitting same query. Now it is performing index scan observe. This one works faster now. What is the advantage we are getting with unique index? In future, if anyone is inserting duplicate values like this, insert into department values, 60th department, HR, okay, or sales, already sales is there, 30th department name sales only. Again, I am giving 60 sales Delhi, I am giving. Already sales department information is there, sir. Again, I am inserting sales, duplicate value, error. Who is controlling us? UI1 violated. UI1 violated is selling observe, sir. UA1 is not primary key. UA1 is not uh, unique. Okay, UA1 is what, sir? Unique index. Unique index is controlling us from entering duplicate values or not. That is why on unique valued column, it is better to create unique index. Is this point clear? Understand this point now? To see indexes information, there is one ready-made table is there, user underscore indexes. See here, these many indexes are there, observe. Okay, how many indexes are there? Notice here, how many indexes are there? 27. Now I am creating one new table, observe. Create table T 1, 2, 3, 4, 5, 6 F1 int constraint 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 name. Okay, constraint name constraint type primary key. Like this, I am creating the table. So when we create the table on primary key column, implicitly one unique index will be created. On F1 column, implicitly Oracle creates unique index with the name, with constraint name, with the C123 name, implicitly unique index will be created. Check here. Previously, how many indexes were there? After creating this in table, implicitly on F1 column, one unique index C123 will be created. How many indexes are there now? Are you understanding? See here, table created, observe. See the indexes. How many indexes are there? 28. Here index created or not? See 123. Observe. Index name. Index name. See 123. With constraint name only. Constraint name. It is taking as index name now. Constraint name it is taking as index name. See 123 unique index created. That's it, sir. With unique index, the advantage is in future, if anyone is inserting duplicate value, it will not accept. Because of unique index only, primary key does not accept duplicates. Insert into T1, 2, 3, 4, 5, 6. Just now we created this table. Values 1 accepted. Again 1. Unique constraint violated. It is telling. What is this one actually? This is unique index name. In the constraint chapter, I told what? Constraint name. But constraint name and unique index name same. Actually, it is unique index name. This unique index is restricting us from entering duplicate value. Are you understanding? That's it. This is about B-tree index. B-tree index topic is over. What is B-tree index? When we create index, if B-tree is created like this, that is B-tree index. What is simple index? If index is created on one column, simple index. What is composite index? If index is created on multiple columns, composite index. What is function based index? If index is created on function based index. What is unique index? On unique valued column, it is better to create unique index. With this, it does not accept duplicates in that column. Successfully, we finished B-tree index, sir. If it is clear, we can start bitmap index, last topic, sir. Is it clear? Unnamed students, please confirm. Is it clear about B-tree index? Who is this Praveen? In the initial classes, I provided syllabus. So because of such kind of candidates will be there, that is why I provided syllabus. And I announced that whatever is there in the syllabus, that one only I cover. This point I already told. In the notes in the front page, I provided syllabus, sir. Why I provided? Next, bitmap index. Bitmap index. This is interview question. Interviewers ask like this. What are the differences between B-tree index and bitmap index? What are the differences between? Okay, listen, Mr. Praveen. Actually, this performance tuning, query optimization. Okay, this. Okay, you learn generally in DBA course. Even in our course also, I explained performance tuning. Performance tuning is that is related to all concepts. Bulk collect improves performance. Bulk bind improves performance. Today I explained index. Index improves performance. Materialized view. Materialized view improves performance. This is performance tuning. All these concepts are improving performance only. If you want additional knowledge, join in DBA course. Okay. So because of such candidates will be there, that is why I announced the syllabus very clearly. In the syllabus front page, I provide this one. That is why. And in the first class only, I clearly told I go through with this syllabus. I cover these topics. Like this I mentioned. These all topics I covered. You can cross check it. I hope you understood. Next, B-tree index. What is B-tree index, sir? In this, B-tree will be created. In bitmap index, B-tree will not be created. Next, in B-tree index, values and row IDs will be stored in leaf nodes. So B-tree index contains values and row IDs. In B-tree index, values and row IDs stored. In bitmap index, zeros and ones will be stored. This is the difference. In B-tree index, values and row IDs will be stored. In bitmap index, zeros and ones will be stored. When to create B-tree index, when to create bitmap index? On high cardinality columns, create B-tree index. On low cardinality columns, create bitmap index. Low cardinality column means less distinct values. Low cardinality column means less distinct values, sir. A column which has less distinct values, that is called a low cardinality column. A column which has less distinct values. A column which has less distinct values, that is called low cardinality column. For example, best example to understand this is gender. Assume that 1,000 employees are there. First employee male, second employee female, next employee female, next male, 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 female, 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 male, female. Like this data is there. Like this 10,000 employees are there. How many distinct values are there in the gender column, sir? Huh? Is it low cardinality column or not? On low cardinality columns, it is better to create bitmap index. Okay, employee number, low cardinality column or high cardinality column? High cardinality column, 10,000 employees are there, 10,000 distinct employee numbers will be there. E-name, high cardinality column, salary, high cardinality column, many distinct values. 10,000 employees are there, 10,000 different names may be there, possibility. 10,000 unique employee numbers are there. That is why on employee number primary key, internally, it is creating B-tree index. Unique index is B-tree index only. On low cardinality columns, we create bitmap index. Low cardinality column means a column which has less distinct values, like this, gender, less distinct values. 10,000 values are there. Two distinct values are. On low cardinality columns, it is better to create bitmap index. Suppose there is a table is there, student 490, student ID, student name, gender, male, female, female, male. Like this data is there. My frequent operation is retrieving data. My frequent operation is retrieving data based on gender. So I'm submitting like this. Select star from student 490 where gender equals to male. Which scan will be performed? Which scan will be performed, sir? Table scan. On gender column, we didn't create any index. Gender low coordinate column or high coordinate column? Huh? Okay, which one is better? B-tree index or bitmap index? Huh? How to create bitmap index? Create bitmap index BI1 on which table? On which column? The bitmap index created. Again submit like this. It performs indexes scan. It works faster. Okay, what happens implicitly? Implicitly, what happens here is when we create the index BA1 by taking these distinct values as the column headings, it creates bitmap index. In this, bits will be stored. 1 means understand like true, 0 means understand like false. First employee male, first student male, male value 1, female value 0. Male, male value 1, true, female value 0, false. First student male, so male value 1. Second student female, so female true, male false. Like this, bits will be stored. Next student female, female value 1, male value 0. Next student male, male value 1, female value 0. Did you understand how it is storing zeros and ones? First student male, male value 1, female value 0. Second student female, so female value 1, male value 0. 1 means true, 0 means false. You can understand like that. Like this, bits will be stored. Okay, so when I submit query like this, when I submit query like this, gender equals to M. So in the M column, ones will be selected now. Is this 1? Yes. Is this 1? Yes. These are not ones. Will not be selected. Ones will be selected. Here every bit linked with row IDs. These bits will be converted to row IDs. Bits will be converted to row IDs. Every bit is linked with some row ID. Using these row IDs, it picks the records like this. Once again, I'm telling. When I submit query like this, gender equals to M. From M column, 1 bits will be selected. Is it 1? Yes. Is it 1? No. Is it 1? No. Is it 1? Yes. 1 bits will be selected. This bits linked with row IDs. So this bits will be converted to row IDs. Every bit is linked with row IDs. This bits will be converted to row IDs. Using this row IDs batch, table will be accessed. We get mails records now. Like this it works. That's it. Let me show this one only. I am creating this table now. Create a table. Last table in our course. 490. SID. Number of 4. S name. Varchar 2 of 10. Gender. Char. Bracket close. Semicolon. Table created. Insert the records now. Insert into student 490. Values. First record 1001 A male. One row created. Let me insert second record 1002 B female. 1003 C female. 1004D mail. Like this data is there. To see the execution plan, set auto trace on explain. Set auto trace on explain. Observe now. Okay, see here. So to see the execution plan, we are setting auto trace on explain. Already I used that command. One more time I type it. Okay, now observe now. My frequent operation is retrieving data based on gender. So I'm writing like this. Select star from student 490. Select star from student 490. Where gender equals to male. Table scan it is performing. I want to improve performance of it. Gender low cardinality column. Gender low cardinality column. So it is better to create bitmap index. Create bitmap index. Bitmap index name on student 490. Okay, which column? Gender. Bitmap index created. Again, I'm submitting same query. Bitmap index scan it is performing. See here. Bits converted to row IDs using row IDs table access. Bits converted to row IDs using row IDs table access. That's it. On high cardinality columns, create bit index. On low cardinality columns, create bitmap index. To see indexes information, use user underscore indexes. To drop the index, right? Drop index name. That's it, sir. So this is about course. So in our course, in module 1, we discuss about tables. Okay, in that 7 chapters I covered SQL commands, functions, giants, subqueries, constraints, clauses, set operators, like that. 7 chapters I covered. In module 2, PL SQL complete programming language we discussed. 11 chapters I covered here. In module 3, other database objects, 5 database objects I covered here. Okay, like sequences, synonyms, materialized views, okay, views and indexes. So this is our course, sir. Successfully, we finished Oracle, SQL, and PLSQL course. Thank you, everyone, for your cooperation and for your regularity. Okay, appreciate you all. Every day you came, some of you. Every day you attended. You maintained regularity and time punctuality also. Appreciate you till the end. Every day you came and you attended. And you have given excellent responses. Even if less strength is there, okay, you have given excellent responses to me. Thank you, everyone, and all the best for your bright future. Okay, bye, everyone. Thank you. Huh? Hmm. ఆల్ఫాబెట్స్ లో కూడా సేమ్ ఇంటర్నెట్ అయితే ఇండెక్స్ తీసుకుంటాం ఆల్ఫాబెట్స్ లో A to Z మధ్యలో M N ఒకటి కీగా తీసుకోండి ఎనికి తక్కువ ఉన్నాయండి లెఫ్ట్ సైడ్ ఎనికి రైట్ సైడ్ ఇంటిగ్రేట్ చేస్తాం కానీ ఇంటిగ్రేట్ వాళ్ళు మళ్ళీ ఇది అవసరం అంతే నేర్చుకోవాలి ఇది జాగ్రత్త Okay, Mudassir. Good, very good. All the best. All the best, Mudassir. Thank you. Online students, thank you everyone. Thanks a lot for your regularity and cooperation. Okay, all the best for your bright future. Thank you, everyone. I'm leaving the session. Bye, everyone.